Welcome students. Today we will talk about maximum minima of a multivariate function. So let's start. See, if we consider a multivariate function, say x square plus y square minus xy minus 2, okay, then we all know that this expression will give you a real number for a certain values of x and y. And if we put this as an equation, then it represents a certain curve in xy plane. Okay. We are assuming that this equation is representing this curve. Okay. See, we can clearly see that at this point and at this point the function has max value and the function has mean value. Okay. But every time we cannot draw the picture of the equation. Okay. That is why we have to take help of calculus. And today I will show you how to determine maximum and minimum of a certain function without drawing a curve. Okay. Now I am defining what is maximum value and what is minimum value. Okay. Let f x2r be a function where s is a non-empty subset of R2 and let a comma b be a point from the domain S. Then f is said to have a maximum value at a comma b if there exists a suitable region n of a comma b such that for all points xy belongs to n, f of xy is strictly less than f of a comma b, and f is said to have a minimum value at a comma b if there exists a suitable region n1 of a comma b such that for all points x comma y belongs to n1, f of xy is strictly greater than f of a comma b. But when we will do problems to find a maximum or a minimum value of a multivariate function, then these definitions are not so very useful. Okay, so we have to state a statement, a very powerful statement of a powerful theorem, so that we can use that statement in our problems. Okay, let f be a function from S to R where S is a non-empty subset of R2 and let a comma b belongs to x. Suppose f admits of continuous partial derivatives of first order and second order. That means if we partially differentiate f, then the first order and second order partial derivative has to be continuous. Okay. And let fx at a comma b and fy at a comma b is equal to 0. Then we shall write a is equal to fxs at a comma b, b is equal to fxy at a comma b, and c and sorry, C is equal to f of y at a comma b. Okay, and let h equal to ac minus b square. If h less than 0, if this h less than 0, then f has no max or mean value at point a comma b. That means if h less than 0, then f has no max or mean value at a comma b, and this point is called as saddle point of f. Okay, if h greater than 0, if this h is greater than 0, then f has an extreme value. Extreme value means it has max or mean value, or mean value, max or mean. Okay, at a comma b, the value is maximum if a and c are both negative. If this a and this c both are negative, and minimum at a comma b if a and c are both positive. If h equal to 0, then the case is undecided. Now our first problem is examine maxima and minima of the function f of x comma y is equal to 2 into x square minus xy plus 2y square minus 20x. Okay, see, one thing I have not told you, that see, if you have a function, say z equal to f of xy, okay, then we have to obtain the fx, that is a partial derivative of f with respect to x, and fy. Okay, and we have to solve fx and fy is equal to 0. This we have to solve this two equations. Okay, the solutions of these two equations are called critical points. Okay, so definition, let z is equal to f of xy. For example, let fx and fy be exist. Then the solutions of this system of equation. Okay, then the solutions of this are called critical points. Critical points. Okay. And the maxima or minima will occur at this critical points. See, if you have to determine maxima or minima of certain function, then you have to calculate the critical points. Okay, the maxima or the minima will occur at some critical points. At this, not at some critical point, not all. Okay. So, at a certain critical point, maxima or minima will not occur. But if maxima or minima will occur at some point, then that point will be critical point. Okay. And that is why we have to just check the critical points. We have to just determine the critical points of the function f. Okay. So in this problem, we have to determine all the critical points. So we have to solve the equation fx and fy. So what is fx? Fx is equal to 4x minus y minus 20, and what is fy? Fy is equal to 0 minus x plus 2y and 0. Okay. 1 and 2. See, solving 1 and 2, we have solving 1 and 2, we have y is equal to 4 by 3 and x is equal to 16 by 3. So this function has only one critical point. Okay. So we have to examine the max or the mean value at this point. So the only critical point of f is okay. To investigate whether this point is an extreme point or not. Okay. So we have to calculate A, B, C. So what is it? A is A is f of x. What is B? B is f of xy. F of xy. What is C? C is f of yy. F of yy. So, see, what is f of xx? F of xx is del of del x of fx. Del of del x of fx. And this is partial derivative of fx with respect to x. And that will be 4. That will be 4. What is f of xy? We have to partially differentiate fx with respect to y, and that will be minus 1 del of del y of fx minus 1. And what is c? C is del y of fy. And what is fy? 4y minus x. So c is only 4. Okay. So h is equal to ac minus b square. AC minus b square. And okay, 4 into 4 minus this is 15. Okay, greater than 0. By the previous theorem, if h is greater than 0, then the extreme value of the function f will occur at this point. But at this point, okay, and since a and c are both positive, h is greater than 0 and a and c are both positive, then at the critical point 16 by 3, 4 by 3, the minimum value will occur. But what is the minimum value? See, so the minimum value of a will occur at 16.3. Okay. Now what is the minimum value? Just you have to put the x and y in this function. Okay. 2 into this will be this is the minimum value. Okay, for this function. Our second problem is find the maxima and minima of the function x cubed plus y cubed minus 3x minus 12y plus 20 is equal to 0. Okay. No, 4. 20. F of xy Find also the saddle points. Okay. See. At first, what we have to do? We have to do the partial derivative of f with respect to s. This is 3x square. Okay. 3 and fy is 3y square minus 12 and consider fx equal to 0, fy equal to 0. Okay. So we have to solve these two equations. See, 3x square minus 3 is equal to 0. So x square minus 1 is equal to 0. And 3y square minus 12 is equal to 0. It will be y square minus 4 is equal to 0. Then what will be the x? X is equal to plus minus 1 and y is equal to plus minus 2. So our critical points are 1 plus 2 minus 1 minus 2 and okay, these are our critical points. And f of xx is 6x and f of yy is equal to 6y and f of xy is equal to c. Here is no y, so f of xy is equal to 0 for all xy. Okay. Now we have to determine h. What is h? h is equal to ac minus b square. And what is ac and b? A is equal to f of xx at the point a comma b, where we have a comma b means the critical point. B is f of xy at a comma b and c is f of yy at a comma b. Okay. Now what is h at at 1 comma 2? That will be fxx at 1 comma 2, fyy at 1 comma 2 minus fxy at 1 comma 2. Okay. Say what is fxx? That is 6x for all xy. So if we put the value 1, then this will be 6. What is this? 6 into 2. And what is fxy? Fxy is 0 for all xy. This will be 0. And this will be 12 into 6 greater than 0. Okay. So the extremum will occur. And since h greater than 0 and a and c are also greater than 0, then the minimum value will occur at the point 1, 2. So the minimum value will occur at 1, 2. Okay. Okay. Now we have to check the other points, the other critical points. Okay. So we have to use these lines and now h of h of minus 1, 2 is equal to, see, what is f of x at minus 1, 2? That will be minus 6. And what is f of y at the point minus 1, 2? And that will be that will be okay, 6 into 2. And this is less than 0. So by the above theorem, by the previous theorem, this is less than 0 at the point of minus 1, 2. So no extreme value will offer at minus 1, 2. Okay, and minus 1, 2 is the saddle point. Minus 1, 2 is the saddle point. Okay. Now I am giving homework to check what will happen at minus 1, minus 2 and 1, okay. This is homework. One of these points will give you another saddle point, and one of these points will give you a max point. Okay. problem number 3 is a top open rectangular box has capacity 32 semi-cube. Find the dimension of the box so that the total surface area is minimum. Okay. See, apparently this problem is looking like very hard, but if you read the line, find this line, find the dimension of the box so that the total surface area is minimum, you can understand that here the function is the surface area, okay? And we have to determine whether the surface area is minimum, okay? So we have to determine the point at which the surface area function is minimum, and that point is nothing but the dimension of the box, okay? So answer, the total surface area of the rectangular box is, see, this box is top open, okay? This is a top open rectangular box. So when we will write the surface area, the total surface area of the rectangular box, then we will not consider this surface, okay, this top surface. So okay, we have to at first assume the dimensions. Let x, y, z be length, breadth, and height of the box, okay, of the box. So the volume of the box is B is equal to 32, and which will be x, y, z. And the total surface area of the top open box is, okay, top open box is equal to xy plus 2yz plus 2xz, okay, because this top surface is open, okay, that is why we have not assumed the area of this surface. Now it is 1. Now putting the values of z, this is 2. No, this is 1, this is 1, and this is 2. Now putting the values of z, value of z, from 1 in 2. So s is equal to xy plus 2y. What is z? 32 32y xy 64 by x and 64 by y. Okay. Now we have to determine the critical points. Okay. Consider x is equal to 0 and sy is equal to 0. What is x? X is y minus 64 x square is equal to 0. What is sy? Sy is y x minus 64 minus y square is equal to 0. Okay. And if you will put value of x in this equation, then you will get putting the value of x in 4. No, it is not in 4. Value of x in 3. So we have y 64 is equal to 0. Okay. Y cannot 0. Okay. So 164 is equal to, this will give you y is equal to 4. Y is equal to 4. Okay. And from 3 we have x is equal to 4 and z is equal to 3. So I am using all of this and just our critical point is our critical point 2. Okay, and see now each of 4 comma 4 comma 2 is equal to a4 x6 at 4 comma 4 comma 2 a4 y 4 comma 4 comma 2 minus okay. Now what is a4 x6? See, if you calculate f of x, then this will be no. If you calculate f of x, then this will be sorry f of s of x, then this will be okay. So it will be 1. Okay. So each of 4 comma 4 comma 2 sorry, is equal to this will be 1. Sorry, this will be 1. This will be 1. Okay. And simply this will be the potential. And since s x greater than 0 and s y greater than 0, so since h greater than 0 and a greater than 0, c greater than 0, so that s will be minimum. That is when the dimensions are 4 cm